Hey everybody, it's Mr. G. Welcome to this episode of Just Corvette Crazy. Today we're going to be looking at one of the most underutilized tools in the garage, and that is a multimeter. Multimeter, we're going to be looking at four major types of measurement. We're going to be looking at resistance, continuity, voltage, and current. So stay tuned. Hey folks, this is Mr. G and welcome to Just Corvette Crazy. On this channel we talk about Corvettes, we fix some Corvettes, and we love to drive our Corvettes. So if you like what you see, hit that subscribe button. It really helps the channel out a lot. Thanks. Alright, so there are many types of multimeters out on the market. Many different manufacturers, different qualities, but there are two main differences between multimeters. They all measure the same thing, but how they measure it might be a little bit different. I have here in one hand an auto-ranging meter. This auto-ranging meter is made and distributed by the same company that distributes this one, which is a manual ranging meter. The difference between the two, when I'm using this particular meter, all I have to do is set up the meter, connect my leads, and turn it on. The meter will do the rest. It will automatically choose the best range for the most accurate reading for whatever element I am looking for. This one, as you can see, has a number of different ranges for each type of reading. So as an example, there's 1000 volts, 200 volts, 20 volts, 200 millivolts, 20 millivolts. What this does is allows you to manually select the range. What that means is if I have this set for 1000 volts, that means that this meter can measure up to 1000 volts and display it on that screen. If I select this 200 volts, then that means that this meter will display up to 200 volts. It allows you to choose the accuracy, therefore the amount of decimal places for your reading, whereas this meter does all of that for you. So let's see how they work. Alright, so the first type of measurement we're going to do is resistance. The unit for resistance is called the ohm. The Greek letter omega is the symbol for ohm. So I can measure 200 ohms. So ohm is the actual unit. So what is resistance? Resistance is opposition to electricity. The more resistance you have, the less electricity is allowed to flow. The lower your resistance, the more electricity is allowed to flow. So again, the more resistance you have, the less electricity. The less the resistance, the more the electricity. So let's take a look at an example of where we might measure resistance. So what I have here is a fuel injector. This is the same fuel injector that you saw me install on the C4 Corvette. I have here just a connector. So this is where the connector would plug into the fuel injector in your car. What a fuel injector is an electronically controlled valve. It's a solenoid. electricity enters in on these two pins and causes a solenoid to open inside the injector, allowing pressurized fuel to flow through it. Remove the electricity, the valve inside the solenoid closes, stops the electricity from, or stops the fuel from flowing. So, adding electricity opens up this injector. The way this works is there's a coil, so an electrical coil inside this device that magnetizes and opens up the solenoid. We can actually measure the resistance of that coil. So what we're going to do is I'm going to first do it with the auto-ranging meter. So I select ohms on my auto-ranging meter. There are 4 inputs. The black one typically goes into the common. The red one is going to go where the ohm symbol is on the meter. Plug it in. So now what I'm going to do is I'm going to connect my ends to the coil on that injector. So basically, just right to those 2 pins. Then I'm going to turn on my meter. So 15.2, 15.3 ohms. The injector rating, the coils, are somewhere between 15 and 16 ohms for that C4 Corvette. So this one falls right in with it. Now, some of the issues that I could have, if this was reading zeros all the way across, then that would mean that my coil inside is shorted. If I was reading something that looked like this, that means that the coil inside is open circuit. So that means it has blown up, blown open. So in my meter, on this particular meter, OL means open load or overload. Allow a value that is greater than what this meter can measure. So overload. So what that looks like in this meter is OL. Every meter is different, and I'll show you what my other one looks like as well. So a good reading on this particular injector, 15.2, 15.3 ohms. So now let's take a look at the same reading on the other meter. Alright, so let's see what that looks like with the manual ranging meter. So again, I have connected the leads to the injector. And you'll notice that I'm displaying here zeros across the board. This right now is set to measure 20 million ohms. 15 ohms doesn't register in that scale. So what I'm going to do is I'm going to adjust this. And as I go down in the scale, eventually you're going to see a value showing up. Oh, there we go. We're starting to get close. And we keep adjusting the scale until we get to the best reading with the most decimal points. So again, 15.2, 15.3 ohms on this injector. So the disadvantage of the manual range meter is that you have to select the actual range. The advantage is you can control how many decimal points you see displayed. So that is a measurement of resistance. Alright, so the next thing we're going to look at is continuity. And what continuity is actually a lack of resistance. So a resistance of approximately 0 ohms. The ability for current or electricity to pass through something unimpeded. As an example, so I'm going to take this connector from my injector, and I'm just going to test the continuity of, let's say, the black wire. So what I'm going to do is I'm going to set up my meter, and I'm going to use the auto-ranging meter because it has a really nice beeping function. So what I'm going to do is I'm going to set it up for continuity. That's the symbol there on my meter. And the red wire is going to be plugged into the continuity, same symbol. And the way that it works is if there was continuity between these two wires, so between the two leads of the meter, this is what it looks like. You hear the beeping noise and it displays 0 resistance. That means that now there is no resistance between these two wires, between these 2 points. So what I'm going to do is I'm going to test the continuity of this black wire. So let's pretend that I was suspecting that this wire was broken. So just like measuring resistance, continuity does not have a polarity. You can put the black and lead, whatever. Just like in resistance, you want to make sure that there's no electricity flowing through the wire or whatever it is that you're trying to measure. So now what I'm going to do is I'm going to take this lead and I'm going to poke it into the connector, and if there is continuity on that wire, I will hear my beep. There we go. So there's my beep and there's my 0 ohms. So that means that there's continuity on this black wire. So from this end of the wire to where it comes into contact, and it's hard to get the lead in there. There we go. I have continuity. Okay. So again, very important, no electricity must be flowing through the circuit when taking this measurement. Same thing with taking a measurement of resistance. A measurement of resistance cannot be taken with electricity flowing through the circuit. So make sure that whatever it is disconnected from the electricity source. All right, the next element we're going to be looking at is voltage. Voltage, the unit is the volt. The symbol is V. There are 2 types of voltage readings. One is called AC and the other is called DC. Alternating current, direct current. Alternating current means current is flowing one way through a circuit, then back. Direct current, current is always flowing in one direction. In automotive, the system is a DC system. A battery has a positive side and a negative side. And current always flows in one direction. And we talk about what's known as conventional current flow, where current will flow from the positive side of the battery to the negative side of the battery. That's called conventional current flow in DC. So voltage comes in 2 types, AC and DC. AC is what you're going to find in your house. DC is what you're going to find in your car or systems that have batteries. So now what we're going to do is I'm going to take you over to the car and show you a measurement of voltage. Alright, so here we are at the battery of the Z06. And I'm just going to show you a measurement of voltage using the battery. Now, what voltage is a potential energy difference between 2 points. That energy or potential energy difference is what pushes the electricity through your circuits. So, in order to measure voltage, first we're going to do it with the auto-ranging meter. First thing I must do is I must figure out what kind of voltage that I am going to read. So, a battery is DC voltage, DC voltage. I must also realize that on this meter, the voltage input for the red lead is over here. Now, black lead goes to the black post of the battery. The red lead to the red post of the battery. And I'm getting a reading of 12.42 volts. If I reverse these leads by accident on a digital meter like this, no big deal. It will just read as a negative voltage. So the negative. So that means that in this particular case, I have my leads reversed. If I was to do this same measurement with the manual meter, the volt input is over here. I am going to go to DC voltage, start at my 1000 volt scale. I know that there's not 1000 volts on my battery, so I'm going to hook up. And I'm getting 12. Watch what happens as I go down the scale. I start getting more and more decimal points. Here we go. Now, if I go too small, I get this 1. This 1 represents I'm out of the range of the meter. So we can't actually read what's on this scale. So I'm actually at 2 volts, trying to read 12 point something volts. So in order to do that, the most accurate is the 20 volt scale. Now, one interesting thing to do with the meter is to be able to determine whether or not your charging system of your car is working properly. Right now, I've got 12.23 volts. The car is not running. The interior lights are on. The car is kind of woken up and inactive. So we're slowly draining some of that battery. I'm going to go in and I'm going to start the car. And I want you to watch what happens to the battery voltage when I start the car and the alternator kicks in. So when the alternator kicks in, it's going to start charging that battery, and you're going to see an increase on the meter. So you see that increase while the car is running? That's proving that the charging system is charging my battery because the battery voltage increases. Just a real simple test that you can do with your digital multimeter. Alright, so the next thing that you can measure with your multimeter is current. Current is actually the flow of electricity, and it is measured in amps. Capital letter A. is the unit. So, current is measured in amps, and it is the flow of electricity. So if you have a battery, there's the positive and the negative of your battery. You have a wire comes out, goes to a light bulb like this. The electricity that flows through that wire from the positive side of the battery through the light bulb to the negative is a measurement in amps. So, in order to measure current in the multimeter, first thing, there is also AC and DC current, just like voltage. AC current you'll find in your house. DC current you'll find in any source with a battery. So DC is what you're going to find in the car. So what you're going to find is a measurement of DC current. You're going to utilize, in this particular case, there's two inputs for current. One for small amounts of current and one for large amounts of current, up to 10 amps. So I used this multimeter and I measured current that's drawn from on the Z06 in another video looking for parasitic draw. So I'm going to show you how it was done. So here's that video. Here's the meter that we're going to be using. So this is just a typical digital multimeter. It does functions like voltage and resistance, and then what we're going to use it for is current. So we need a couple of leads. So we've got a red lead and a black lead. Now I have an idea that when I first connect my battery, before the car goes to sleep, I'm going to have a little bit more than an amp of current draw. So I'm going to use the 10 amp setting on my meter. So I'm going to plug my black lead into the common, and I'm going to plug the red lead into this connection here that says 10 amps. So that means that I can measure a maximum of 10 amps in this setting. And then I put my selector to DC current 10 amps. And then I can turn my meter on. So let's talk about how we're going to connect it. Here's my battery. The positive side of the battery goes off to my fuse panel. The negative side of my battery goes to the chassis ground. There are two ways that we can connect this meter to measure the current. With the first way, what we're going to do is we can remove the positive lead from the battery, and we are going to connect our meter from the battery. So the red goes to the positive of the battery, and the black will go to the wire that we just pulled off the battery. This is one way to measure current. So the current leaves the battery, goes through this red wire, the electrons get counted, they come back out through the black wire, and then off to my fuse panel and to the rest of the car. So that's one way to do it on the positive side of the battery. Another way to do it is on the negative side of the battery, because every electron that leaves the battery must return. So what I'm going to do is I'm actually going to remove the ground lead. I'm going to take my black lead from the meter and connect it to the battery. Then I'm going to take my red lead and I'm going to connect it to the wire going to the chassis. So now the electrons, they'll leave the battery, go off, do their thing, and come back to the battery, go through my meter, and then return to the negative side of the battery. So that's how we're going to connect it out at the car. So let's take our meter and our concept and go apply it to the car. So the first thing I'm going to do is disconnect the negative side of the battery. So I've got a 9mm wrench. I'm just going to remove the negative battery terminal for the car. And now what I'm going to do is I am going to put or insert the amp meter from the battery terminal to the connector that we unplugged. All right, so I've got the black lead from my battery disconnected. I'm expecting there to be a fairly large current draw on my car. So I'm actually going to use the 10 amp setting on the DC, and I'm going to plug my connector into here. So that way if I have more than 400 milliamps, I'm not blowing fuses and so forth in my meter. So in order to connect the meter up, what you do is you take the black lead and go to your battery, and then you take the red lead and you go to the connector. And you'll see that I'm drawing 2.4 amps of current on this system. All right, in this episode, we learned how to use a multimeter to measure resistance, continuity, voltage of the DC kind, current of the DC kind. We looked at different types of multimeters, whether it be the auto range or the manual range. Now, both of these do the same job. One allows you to pick your range, the other does it for you. So this one is a little bit easier to use. Now, both of these devices require batteries inside to light up the display and make your measurements. So, one of the really interesting things about these meters is that using them to do all kinds of nice meter readings like we just did, fairly simple, and you can keep these in your shop, in your toolbox, whatever. Now, the problem with these is if the batteries go dead, you cannot use them. So, if you were to take one of these and toss it in the back of your car or in your toolbox, you always need to be aware that if the batteries die, the meter will not work. So with that in mind, let me show you something really, really cool. This is a multimeter, old school. So this particular one is what we refer to as an analog meter. This particular device does not require batteries to take voltage and current readings. This one will do it with no batteries at all. This particular meter has been sitting in my toolbox, I'm going to say, for 30 years. And this particular meter will work measuring voltages and currents just like the day it was born. The only thing that this meter requires a battery for is measuring resistance. Other than that, this particular meter will be able to perform voltage and current measurements. So, I've had this one in my toolbox, I'm going to say going on 30 years. It's not as accurate as a digital meter. It's not as easy to use as a digital meter. But the advantage is I don't have to worry about batteries going dead. So I keep this in the toolbox in the back of my car all the time in case I ever need it. It works just the same as the other meters, but instead of a digital display, the needle moves and you have to read off of the scale. So sometimes having an old school meter will serve you better than newer technology. So I keep the new ones in my shop, and I keep that old school analog tucked away in a small toolbox in the back of my car all the time. In case I ever need it, it's there. So that's basically what you need to know about taking some measurements using a multimeter. Lots of different uses for them in your vehicle. Get used to using them. They are really an unappreciated and unutilized tool, especially in today's modern vehicles where everything is all electronics. It's really nice to know that you can pull out a meter and take some measurements and help you diagnose what might be the issue in your car. So until next time, Mr. G says, keep the rubber side down, everybody, and take care of yourselves.